I would call the easiest way to solve systems, especially if these equations they give you are graphable, and that you have graph paper, because it's real easy to spot solutions here. So 2 key points before you get going. You're going to be graphing 2 or more lines. That's what we call a system, 2 or more equations, and seeing where they all intersect, because that intersection point is the solution to these systems. So if I see 2 lines cross and it says what is the solution, I'm just looking for that point where they're both crossing. So let's get going. Alright, so on this you've got 2 equations graphed, and they're linear. They're both lines. And right off the bat you should be seeing what the solution is. It is very easy, like I said, to spot these solutions. So right off the bat, if it said what is the solution to this system, you should just be pulling this point off, which is 1, 1. So the solution here would be the point 1, 1. Now, while we're here, kind of want to recap, because they could also ask you this. It could say, well, the solution is 1, 1. It should, if they give you that, cool. But then they're going to ask you a question about the actual lines. They should say probably something like, the solution is 1, 1. What 2 equations produce this solution in this picture? And they would want you to go backwards. So let's look at the red line real quick. And remember, when we're talking about lines, we're talking about y equals mx plus b. So let's look at the red one. I want what the y-intercept is. Well, hopefully you're seeing that's at 2. So that's my b. So we're at positive 2. And we'll have y equals. And then we just need to go figure out the slope. Well, the slope is going to be negative, because look at how the line's pointing. It's pointing down. So we need to go see how far down and over we go to get to the next point. Well, use your solution point that I've circled in green. From that red point down and over, that's down 1 over 1. So that's a negative 1 over 1. So negative x plus 2 is the equation. Alright, for the other one, we need to identify the same 2 things, the y-intercept and the slope. So let's see, y-intercept is down here, and it's not quite exactly at negative 2, but for what we need right now, let's call it negative 2. And then we need to go find the slope. So again, let's use the solution point in green. So from that point, we're going up 1, 2, 3 over 1. So it's a positive 3. So if it said the solution to the system is 1, 1, what is the system? These 2 lines would be your system right here. Alright, next picture. They actually gave you the equations, but the point itself is not really bolded like in the last one. So they wouldn't ask you what the equations are here, because they gave it to you. They would just want the solution, which again is pretty easy to locate. Alright, so the solution here is going to be 2, 0. Now, one thing I do want to point out, when we say something's a solution, it means it works in its true statement producing for both equations. And what I mean by true statement producing is that if we plug this point in to both equations, I should get something that's true. So let's try it. So on this first equation, I plug in 0 for y. I have negative 3 times x, which we have as 2, plus 6. Well, if we keep working this down, you should see that negative 6 plus 6 is 0. 0 does equal 0. That's a true statement in math, and that's what I'm talking about. You should be seeing something that's true. But for this to be the solution of the system, it can't just be true for this one equation. It's got to be true for this one as well. So to check your solution is actually right, we just need to go plug into the other equation as well. Same point. 0 equals 2 times 2 minus 4. Well, 2 times 2 is 4. 4 minus 4 is 0, so again, true statement, 0 equals 0. You have 2 true statements, you have the correct solution right here. So that's just a quick way to check that you are actually correct. Alright, same thing for this one. Let's kind of pull everything that we've just been talking about in. So this solution here is kind of obvious, so we'll go with the obvious instead of making it hard. So let's say that this is at negative 2, 2. So we think that's the solution. Well, let's look at what these equations are. So this y-intercept's at negative 1. So one of my equations is something minus 1. And let's go pick us another point. This one looks like a good point, or we could use a solution point. It doesn't matter. But to get from one to the other, I'm going down 3 over 2. So my slope is negative 3/2, and then we're going to put an x. Alright, my other equation, my y-intercept is at 4, so I've got plus 4. And I need to go find my slope. Well, look at this. The points are going up 1 over 1, up 1 over 1, so the slope is just 1. So again, if we want to check that this solution, negative 2, 2, is actually correct, we can just go plug the numbers in and make sure we get a true statement. So the first one, 2 equals negative 3 over 2 times negative 2 over 1. I'm just going to add a 1 on the bottom, minus 1. Work this down. Now these 2's cross cancel. Anything divided by itself is 1. So I really have negative 3 times a negative 1, which is a positive 3. And 2 does equal 2, true statement. But you got to go plug it into the other one too, remember? So you've got 2 equals negative 2 plus 4. 2 equals 2, true statement. So our solution over here is correct. Alright, you're not going to see these this year, but just know that there are other systems as well. So we're going to be talking about line systems, linear systems. But next year you could be talking about parabolas that cross lines. You could talk about circles that cross lines. So I just wanted to make it clear, though, that the concept does not change. When we're talking about any system, regardless of what figure you're looking at on the graph, you're looking for the cross points where it's crossing. So the two solutions here would be 2, negative 3, and negative 3, negative 8. So you're still looking, regardless of what the picture looks like, you're still looking for where these things cross each other, the solutions that count for both. Alright? Now, what do you think happens on this one? I've got two lines. They've produced the equations for me, 2x plus 1 and 2x minus 4. But what we've just discussed for several examples is that the solutions to these are where they cross. And obviously, these are not crossing anywhere. So if they're not crossing, hopefully you're thinking the common sense answer that there is no solution, and you'd be correct. Alright, so if there are parallel lines, you're going to have no solution because there's never a crossing point. So look at why we know they're parallel, because if they gave you two equations without a graph, you should still be able to see it's no solution. Because these have the same slope, we know they're parallel, which means they're never going to cross, never producing a solution. So anytime you see parallel lines, whether they're graphed or whether they just give you equations, know that there's not going to be a solution. Alright, on this one, another special case. If they give you the equation of two lines, but they end up graphing one on top of the other, like exactly on top of each other, same slope and same y-intercept, this means that every single point they share, because one's on top of the other. So they're sharing every single point on this line. So we don't just have one solution. We don't have any solutions. We have infinitely many solutions, because we know that lines have infinitely many points. So you have infinitely many solutions here. Alright, that means there's tons and tons you could pick from. So if this, if this question appears on a test and it says what is the solution, it's not looking for a point. Alright, don't pick a point. Pick infinitely many. Alright? So if you need to pause here to write this down, do so, but this is just a recap of what we just talked about. You have cases, and here's special names for them, that we just talked about. But you have one solution here, you have infinitely many here, and you have no solutions here. So make sure that you know the difference. Alright, examples real quick. So if I want to go graph this first line, I'm going to graph this one in red. My y-intercept is not there. It doesn't look like anything's back there. There's no b. Well, if there's no b, it's at 0. And from there, we do our slope up and over. So it says go up 3 over 2. And for these, I want to keep going to make sure, and I didn't go over 2. Sorry. I want to keep going as many points as I can to get an accurate picture. Alright, that should be enough. Alright, so there's that equation. And now this one I'm going to do in blue. Y-intercept's at 8. And then it says go down 1, right 1. Down 1, right 1. Alright, this one's not crossing at the straightest of points. Let's see. So I think we're actually going to be crossing. This isn't a good example, but we could estimate here. So this one's probably going to be crossing... Oh, you know what I did? Hopefully you didn't do this with me. I didn't even notice that this one wasn't already in slope-intercept. So I need to go back and get y by itself real quick. Look how easy it is to make a mistake. So please be careful. Alright, so let's go regraph this one. Y-intercept's now at 4. This should work now. And down 1 over 2. Oh, look there. That's pretty. Okay. So you already see where they're crossing, hopefully. So the solution point's here, which is at 2, 3. So the solution for these is 2, 3. And I'm going to let you go check if you want to pause and make sure these plug back in correctly to do so. But that looks right on the dot. So let's keep going. Alright, this one, the first one's already in a good thing. Now remember Hoivux on this. Go back and look at that video. If we have y equals, that means we're doing Hoi. So it's a horizontal line at y equals 3. So I'm going to go up to 3 and put a horizontal line through there. Alright, and then this one, I'm going to not do the same mistake over again. I need to get y by itself. So y equals x plus 4. So I need to go up to 4. And then it says go up 1 over 1, up 1 over 1, and we can even go down 1, back 1, down 1, back 1, so we can see where it crosses. So you should be able to see right here is where they cross. So that's at -1, 3. And we knew what the y value was going to be here because it says all y values are 3 for that line. So -1, 3 should be the one that works. And again, you can pause and go check, make sure. Alright, this one, they both need to be rearranged 4 to begin with. So let's get the first one rearranged to begin with. So I'm going to minus 7x on both sides. So 2y equals -7x plus 16. And then divide everything by 2. So y equals -7/2 x plus 8. So it says go up to 8, put a point, and then it goes down 7 over 2. Alright, so that should be enough, hopefully. Alright, and then the other one, -21x minus 6y equals 24. I need to add 21x. So -6y equals positive 21x plus 2y. Divide by -6. So y equals, ooh, this is getting fishy, I can't see. I think that's a positive 21 over negative. So we got negative slope, and 3 goes into both of these, so 7 over 2x. That's not a y, that's a 24. Plus 3. Nope, plus 4. Sorry. Can't see when the grid's. So it says go up to positive 4, and then it go down 7 over 2. And notice these are going to be parallel lines. So if they're parallel, they're never going to touch. There is no solution. Alright, so try these practice problems and pause the video. Just find you a scratch sheet of paper, or if you have graph paper, you can go do that. I picked some nice ones for you, though. So as long as you draw your line straight, you should be able to see it. Number 3, this is a real-world context problem of where you would see systems, and we can just imagine maybe this is non-members of a movie club versus members of a movie club where you get discounts. Because we're talking about, if you read the graph, we've got number of movies at the x-axis, price for the movies on the y, and